Hello class, today we're going to talk about the Pythagorean theorem. Now we've been talking about it a couple days in class, so now it's time to actually make the video of that. So let's talk about Pythagorean theorem. Okay, so what the Pythagorean theorem is it's used to find the length of a side of a right triangle. Okay, so anytime we're going to be using the Pythagorean theorem, we're always going to be using a right triangle. Okay, so let's take a look at what we know about right triangles. Well, in a right triangle, the two sides that form the right angle are called the legs. It's very important to understand. So when we look at our picture here, we've got this side and we've got this side are the legs of the right triangle. And we know that this right angle will always touch those two legs. The side opposite that right angle is called the hypotenuse. So this third side is called the hypotenuse, and it's always going to be the longest side. And it's very easy to find because this right angle says it's over there. Okay, it points to it. Okay, so the right angle makes up the two legs, and the hypotenuse is the side that doesn't touch the legs. And it will always be the longest side of the triangle. Now, one of the first people to recognize the relationship between the sides of a right triangle was a guy named Pythagoras. Now, he was kind of a strange dude, but that's what his name was. And this special relationship is called the Pythagorean theorem. Now, he may not have actually come up with the theorem itself, but he and his people, the ones called the Pythagoreans, did, and they were mathematicians. Okay, so let's find out what the Pythagorean theorem is. It says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So this is in language arts. So we know we're going to add. We know we're going to square some things. What are we squaring? The lengths of the legs. And that's going to be equal to the square of the length of the hypotenuse. Okay, so that's language arts. In math, that means a squared plus b squared equals c squared, where the a and the b represent our legs and the c represents our hypotenuse. Now, it doesn't matter which one you call a or b, whether it be this leg or this leg, because we're adding them together. And it says that you can use the Pythagorean theorem to find the length of any side of a right triangle. So that's what we're going to attempt to do today, is learn how to use the Pythagorean theorem. Now, there are two things that you have to find. Okay? One type of problem that we're going to deal with, you're going to be given both of the legs and asked to find the hypotenuse. The other type of problem that you're going to have is you're going to be given one leg and the hypotenuse and asked to find the other one. So what we're going to do is we're going to work one of each of those to show you how to do that, and then I'll give you one of each to do on your own. Okay, so here is our first problem. Okay, so we have a triangle, and we know that the two legs, because they make up the right angle, are 12 and 16 centimeters apiece, and the hypotenuse is going to be our c. So what we're going to do is we're going to write our formula down. A squared plus b squared equals c squared. Now, that's not something that you have to do, but it's something I highly suggest because it tells you what you're looking for. Okay, and then it becomes fill in the blank. So a squared, that's going to be one of our legs, so I'm going to let it be 12. And then I'm going to square it. Plus 16, and I'm going to square it, is equal to the hypotenuse, but I don't know it, so we're going to leave it as c squared. So once we have that information, we just start plugging in our numbers into a calculator. Now, the calculator that I'm going to use today is going to be one that's found off the internet. It's just Google. And it's going to be the one that, if you don't have a calculator at home, one that you could use. Or you could just use the one on your phone. Okay, so here's the calculator. Now, I need to do 12 squared. So the way we do that, we've got a couple ways. Okay, in this particular calculator, all I'm going to do is I'm going to do 12 times 12, because I know that's what squared means. Okay, now you could use this key right here, the x, y, but I'm going to just do 12 times 12, and we get 144. So we come back to our math, and I write 144. Plus, and now I go back to the calculator, and I do the same thing with 16. So 16 times 16 equals 256. So I come back and I do 256 equals c squared. Now it tells us to add it together. So we do. 144 plus 256 gives us 400 equals c squared. And I didn't have to go to the calculator for that. Now, I don't want to know about c squared. I only want to know about c. So what we do is we do the opposite of squared, and that is square root. So I'm going to take the square root of c squared, and if I do that on one side, I must do it to the other side as well. And the square root of c squared is just c. And so then I go back to my calculator and I find out what is the square root of 400. Well, in this calculator, what we do is you type in, just like we do on our calculators at school, square root, and then type in 400. Oops, hit one too many. I don't have a backspace, it doesn't look like, so I'm going to have to clear that out. Oh, there, that's our backspace. So we hit equals at that point, and we end up with 20 as our answer. So C is equal to 20. Now, it's not complete until you put its label. So 20 centimeters. So when you know two of the legs, when you know both legs of the triangle, and you're looking for the hypotenuse, you plug one leg into A, you plug the other leg into B, you square each of those numbers, you add those numbers together, and then you take the square root of that to come up with the value of C. So in this case, it's equal to 20 centimeters. And since C is supposed to be the longest side of the triangle, it fits. Okay, so that's one case that you're going to have to do with the Pythagorean theorem. Let's try another one. All right, well, in this particular one, we're given one leg and we're given the hypotenuse. So this is the other type of question that you're going to have. One where I give you a leg and the hypotenuse and you have to find the other leg. Okay, so again, we write our formula down. A squared plus B squared equals C squared. Okay, so I'm looking for B, and my 5 becomes my A because it's the other leg, because the 13 is opposite the right angle, so that means it's the C, or the hypotenuse. Okay, so I'm going to plug in my values. So 5 squared plus, I don't know B, so I'm going to leave that as B squared, and I know C is 13, so I do 13 squared. So now I do my math. So 5 squared is 5 times 5, so I know that one. I don't need a calculator for that. 25 plus B squared equals, well, 13 squared is just 13 times 13, and I know what that is also. That's 169. Okay, so now I'm looking for that B squared. So here's where we got to think about our algebra. I need that B squared to be by itself, so I've got to get rid of this 25. So how do I do that? I add its opposite. And if I do that to one side, I must do that to the other. And I end up with B squared is equal to, and when you subtract those, you get 144. Now, I don't want to know about B squared because I know this distance right here cannot be 144 centimeters. So to turn a B squared into a B, I take the square root of B squared, take the square root of 144, and I end up with B is equal to 12, and in this case, centimeters, because I know 12 times 12 will give me 144. So my B is 12 centimeters. Now, that's the two types of questions that you're going to have with the Pythagorean theorem at the basic level. Okay, so the first one is if the hypotenuse is missing. So we plug in our A, we plug in our B, square each of those, add the sums, or add that together to get a sum, and then we take the square root of that to find our hypotenuse. When a leg is missing, we have to do a little bit more algebra because I need to get this B squared by itself. Okay, but once I do that, I subtract the A squared on both sides. We still do the same exact thing to end it up. We take the square root of both sides. Okay, so let's see if you can do a couple of questions on your own. The first question you're going to work is one like the first one. So pause the video and work this problem. Okay, so let's see how you did. So this one, A squared plus B squared equals C squared. So in this particular one, we know both of our legs, so we know our A and our B. So I'm going to let 11 be the A, and I'm going to let 15 be the B. Okay, so I'm going to plug the 11 in and square it. I'm going to plug the 15 in and square it. And I'm going to leave the C by itself because I don't know what it is, and square it. Okay, so we do 11 squared, which is 11 times 11, which is 121, plus 15 squared, which I know is 15 times 15, which is 225. And that's going to be equal to C squared. So this says that we need to add those together. Okay, so I'm going to just do a quick add in my head here. So C squared is going to be equal to, well, 1 and 5 make 6, 2 and 2 make 4, 1 and 2 make 3. So we've got C squared is equal to 346. Now what we need to do is take the square root of that. Now this one doesn't come out as nice as the other ones have in these previous examples. So I'm going to go to my calculator, clear out everything, and actually type this one in because I don't know the square root of 346. So I hit the square root, then I hit 3, 4, 6, and I hit equals, and we end up with a really ugly number. Now, most of the time, when you're doing Pythagorean theorem problems, we're going to round to the nearest tenth, okay, unless otherwise told. So we look at this number right here. I go all the way out to the 0, because if I'm rounding the tenth, I've got to look at the hundredths place. Is this 0 going to be big enough to do anything to the 6? No. So our answer is just 18.6. So C is approximately 18.6, and in this case, centimeters. And that's when I do change my equals to an approximate, because I had to round that answer. Okay, so our C is approximately 18.6 centimeters. Okay, so that is our second example of working a problem where the hypotenuse is missing. So now what if we have one where the leg is missing? So pause the video and answer this question. Okay, let's see how you did. So again, a squared plus b squared equals c squared. So in this particular one, since b is missing, my 3 is going to be my a, and my 5 is going to be my c. Okay, so my a is 3, so I'm going to plug that in, 3 squared, plus, I don't know b, so I'm going to leave b alone. B squared equals, and my c is 5, so I square it. So then I do 3 squared, 3 times 3 is 9, plus b squared equals 5 times 5 is 25. Now I need to get that b by itself. So I need to add a negative 9 to both sides. And I end up with b squared is equal to 16. So now, to turn b squared into b, I take the square root of it. So I must do the same to the other side. And the square root of 16 is 4. So my b is 4 centimeters. Now, most all these examples have been in centimeters for the most part. It can be any label that we have. Okay, and that is the second example of the kind of Pythagorean theorem problem where one of the legs is missing. Now you'll have one more type of problem that we got to work with, and that is a word problem, where sometimes you have to draw your own picture. So this one says a square field has sides of 75 feet. So we draw that. It's a square, and the sides are 75. So if it's a square, all sides are going to be 75. And it says how far is it from one corner of the field to the opposite corner of the field? And this is known as a diagonal. And the diagonal in this case is our C. It is our hypotenuse. So you would work this problem exactly like we did example number 1 and example number 3. So let's try one more picture. We're not going to take the time to work this one, but let's try one more picture to see if we can understand how to draw them. In this one it says a rectangular field has a length of 100 yards and a width of 33 yards. Okay, so we need to draw that. Now typically length is going to be right to left, and width is going to be up and down. So we've got our width is 33 yards, our length is 100 yards, and in this particular problem it says about how far is it from one corner of the field to the opposite corner. So again, we're looking for the diagonal. Maybe you can draw a better one than I did there. Okay, so that's how we work with the Pythagorean theorem. We know that it is, again, a squared plus b squared equals c squared, where a and b are our legs, and c is always going to be the hypotenuse. So until next time,